In this video, we're going to do an example of a word problem that has to do with area and optimization of area. So in this scenario, a gardener has 24 meters of fencing. Okay, maybe that's all they can afford, or maybe that's all that was in stock or whatever. And gardener wants to fence the garden on the side of the house. In this case, we actually have a diagram. Okay, so suppose these are the walls. We don't have to fence those. And they want kind of three separate sections for the garden. You want one for carrots, one for cucumbers, one for tomatoes, all the same size. And we want to know like how big can you make this garden? So whenever you're doing a question like this, um, the first thing you want to do is make a mathematical model, right? For example, you could start by labeling these as the width and the length. And we don't know what those are yet, but we do know that the area of the whole garden should be the length times the width. That's a start. Now, obviously, if there are no constraints on the length and the width, you could just make the garden however big you want. But we do have a constraint, which is that you only have 24 meters of fence, right? What does that fence have to cover? Well, it has to cover these three segments. That's like three widths, okay? So that's 3 times W. It also has to cover this bit. That's the length. So this 3W plus L is going to be equal to the total amount of fencing you have, which is 24 meters. Okay, let's say that everything here is in meters. So, to give you some idea of what that means in case that was non-intuitive to you, let's do some trial and error. Okay, let's say if you choose the width of the garden to be 1 meter, for example, how much fencing does that leave for the rest of the garden? Well, you're going to take out three widths, which is 3 meters. So 24 meters minus 3 is 21 meters for the length. That's how much fencing you have for the length. Then the area would be like 1 times 21, which is 21, right? Let's do another example. What if you tried like a width of 2? Well, if you had a width of 2, you would take up 2 times 3, which is 6 meters of fencing to make those width fencing. So that leaves only 24 minus 6, which is 18 meters for the length. And now if you take a look at the area, that's going to be 2 times 18, which is 36. That is better. And in principle, you could keep going and do trial and error, but we don't have time for that. So we're going to say, is there a better way of doing this? Well, we were just saying that whatever the width is, that determines the length, right? The length is always going to be 24 minus 3 times the width. So the area is always going to be the width times the length, which is 24 minus 3 times the width. Let's write that again outside the table. So if you're doing this without the table, you would say, I know the length is 24 minus 3 times the width. And we're going to sub this into the area formula. The area now is given by 24 minus 3W times W. So if you know the width that you want, you put it in, and that gives you the area of that garden. Great, now you can see it's also quadratic. So when we're talking about the maximum area, we want to find the vertex. So I'm going to show you two methods of finding the vertex. You should know both. Method one is to find the zeros first, or the x-intercepts. So in this case, area is equal to 0, when 24 minus 3w is equal to 0, or when w is equal to 0. This first one you can solve to say w is equal to 8. What do these numbers mean? Well, if the width is 0, that's like you have a very flat garden, just fenced off a wall, and that's it. And if w is equal to 8, well, 8 times 3 is 24 meters, which is all the fencing, so you didn't leave any for the length. So those would be pretty bad gardens. Anyway, that means if you were to plot this, w against a, you have intercepts at 0 and 8. You also know that this one's going to be concave down, because if you expand it, that's like negative 3w squared plus 24w. So the vertex should be at 4 when the width is 4. Now, what's the maximum area? That's when you have A at 4. Okay, let's put in, okay, so we have 24 minus 3 times W, which is 4, times W again, which is 4. That's going to give us 12 times 4, which is 48. So the maximum area occurs, the maximum area is 48 square meters, and that's when the width is equal to 4 meters and the length is 12 meters. Method 2, let's say completing the square. Let's start off with this expanded form, negative 3w squared plus 24w. To complete the square, you'll remember, the first thing you do is factor out the a from the x squared and x terms. So you're going to get w squared minus 8w. Then you're going to complete the square on the inside. So if you take this coefficient of w, which is negative 8, when you cut that in half, that's negative 4. Then you square that, which is 16. So the 16 is going to complete the square. You can't just add 16. You got to also undo that, so negative 16, so you didn't do anything. Now you'll notice we have a beautiful square here. We're not going to touch it. We're just going to write it as a square. W minus 4 squared. And then we're going to distribute this negative 3. So you have negative 3 times w minus 4 squared plus negative 3 times negative 16, which is positive 48. And now you can see you have a vertex form where the width is going to be 4 and the A is going to be 48 at the vertex. So the maximum area is going to be 48 meters squared, and that's when the width is equal to 4 meters. Now when the width is 4 meters, you can calculate that the length is going to be 12 meters like before. So that is this problem. Okay, 2 methods of doing exactly the same thing to find the vertex.